Hi, I'm Chris from 18438 Wolfpack Machina. In collaboration with BTI, we're going to create a series of mechanical tutorials for FTC. In this first video, we're going to go over how to use servos. Our team found it very difficult to fully understand how servos work when we were starting out, and as a result, we broke several of them. In this video, we will go over how to mount servos to the frame of the robot, how to reduce stresses on them, and protect servos from breaking. Lastly, we'll go over how to work around the limitations of goBILDA servos, including the differences between default and continuous rotation mode, and how to zero them effectively. To begin, I'm going to give a brief overview of what servos actually are. Servos are lower power, lower speed motors that have great positional precision. They're very different from DC motors and are used very differently in FTC. DC motors are used generally in places where you need strong continuous power, such as an intake or to move your drivetrain. Servos, on the other hand, are used in places where not much power is necessary, but precision is much more important, such as a claw. We use servos in various spots in our robots. For instance, we use them, as I've mentioned before, on a claw to move the outer rollers of our intake, to rotate up and down our intake ramp on our robot from Freight Frenzy, also to control our shooter, and to move around our bucket. So servos are very useful in specific scenarios in FTC. An important distinction when working with servos is the difference between servo mode and continuous rotation mode. goBILDA servos, which we're specifically going to be focusing on, are dual mode servos, which allow you to switch between servo mode or continuous rotation mode. Now I'll get into the differences between those two modes. In continuous rotation mode, the servo has the ability to spin continuously either clockwise or counterclockwise, but it cannot return any position data when it is doing that, so it is helpful for specific scenarios where you're trying to spin something, like a duck spinner, but not helpful if you're trying to get specific positions on something like an outer roller for an intake. The other mode that a servo can be in is servo mode. In servo mode, servos have accurate positioning data, but only within 300 degrees of range. So this is helpful for things where you are trying to go to specific positions, for instance, on our shooter from last year, or on, as I mentioned before, an outer roller for an intake. To switch between continuous rotation mode and servo mode on goBILDA servos, you'll need to use their servo programmer, which you can see here. The servo programmer has 4 buttons on it, the left button and the right button, which in continuous rotation mode will get the servo to either spin clockwise or counterclockwise, or in servo mode to go to its max position in the clockwise direction and its max position in the counterclockwise direction. When switching between the two modes on a servo programmer, you need to first slide the switch on the top left of the servo programmer to either the C, which is for continuous rotation, or the S, which is for servo mode. Once you have slid it to either servo mode or continuous rotation, you can then hold down the center button until the lights on the servo programmer start flashing. And that's when you will have successfully switched the servo to the desired mode. Then, if you press the left and right buttons, it should have a different effect than before when it was in the opposite mode. If you're using a servo in servo mode, you will also need the servo programmer to zero the servo before you use it. Since the 300-degree range of motion of a servo in servo mode is fixed, you need to be careful that the servo's motion lines up with the motion of your subsystem so that it can actually complete the intended task. For example, we need to make sure that the minimum position of our servo moving our claw here was far enough in so that the claw could actually close. If we didn't zero the servo correctly and the minimum position for the claw was too far out, then we wouldn't have actually been able to close the gripper as intended around the wobble goal. To give you an example of how to zero a servo, we'll show you how we zeroed our claw mechanism. First, we took the servo gear off of the servo so that the servo could spin without actually moving the claw. Then we set the servo to its all the way in position. It's important to note here that if you're using a gear train similar to this, where it has 2 gears, that the servo will spin in the opposite direction of the claw. So if you want to have the claw all the way in, you need to spin the servo all the way to its max direction in the clockwise direction. After we did this, we moved the claw to its in position and reattached the servo gear onto the servo. Now, using the servo programmer, we can switch between its minimum and maximum position, and you can see that the claw has the full range of motion it needs to be able to close on the wobble goal and drop it. After your servo is in the correct mode and correctly zeroed, you still need to be careful about how you mount it onto your robot. There are various options for mounting servos. goBILDA on their website sells servo plates and servo frames, which you can mount your servo to. Additionally, if you have access to a CNC machine or some other way to cut custom parts, you can create your own custom plates for mounting servos. It is important when mounting your servos to make sure that they are very well secured. However, the 4 plastic screw holes on a servo are very fragile, so it is a good idea to use washers on top of your screws or standoffs to make sure that when you tighten the screw, the plastic itself doesn't fracture or break. There are many important considerations you need to take when using a servo to power a subsystem that we weren't aware of when we first started out. One of the first things that we learned that was super important is that it's not a good idea to ever directly power a system off of the servo spline. Servo splines are really easy to break, so if there's any force added to the system, the servo would likely break and never be usable again. To get around this, one of the methods we use is gear trains. goBILDA sells servo gears which attach directly to the servo spine but mesh with other gears on their website so that the servo isn't directly attached to the thing moving, which is the claw in this case. When using a gear train, you need to be careful of how the gear ratio affects the servo's range of motion. Specifically, if you gear your servo to increase the torque in the system, your range of motion will decrease by the same factor as the gear ratio. Another method we use for getting power from a servo is linkages. Linkages are good for situations where you only need a small range of motion because they only work through a small part of the servo's rotation. One unique usage of linkages is that they're very easy to spring load. For example, on the outer roller of our 2020 Ultimate Goal robot, we used a chain of zip ties which would deform if the outer roller was hit by another robot, thus protecting the servo from the contact of another robot in play. Lastly, if there is ever a situation where you do need to power a system directly off of the servo spline, goBILDA's servo blocks are a good system to use because they directly support the servo spline, which will protect it from breaking. When we were starting out as a rookie team, there are many things we didn't know about how servos worked. For instance, if you tell a servo to go to a specific position, it will try to go to that position until they break themselves. So if you are trying to open a claw and you are too close to a sidewall, the servo will keep pushing the claw into the wall until the servo itself breaks. We also didn't know how susceptible servos themselves were to blunt force just to the system. So if you were to hit something like, again, a claw on a wall, it would easily break the servo spline and then the servo would no longer function. Servos are super important and will control many of your subsystems each year, but they can be difficult and unintuitive to work with. Hopefully though, this video will give you a good understanding of how to work with goBILDA servos and how to work around their limitations.